Let's talk about ghost voltages and how a low impedance function on a multimeter can help you determine if you have a ghost voltage or not. I've simulated a ghost voltage by putting AC power into one of these wires, and the other wire I'm leaving open. Now both of these wires are coiled around next to each other, and it's a little bit of an exaggeration of having wires coiled around, but I'm trying to simulate a long run in a factory where you might have one live wire sitting in a piece of conduit with a wire that's not connected sitting next to that conduit for that long run. So here I've got a long run of wire sitting next to a long run of wire that's not connected to anything. If I take a non-contact voltage tester, it shows you how current flowing through a wire generates an electromagnetic field. That's how non-contact voltage testers work. They detect that electromagnetic field. So when I get close to these wires, I'm detecting that electromagnetic field in a live wire, but that field is coupling into the wire that's not connected to anything. So I'm seeing that field all over these wires. That means that when I go to measure the voltage coming out of these wires, I'm going to have a ghost voltage there. So let's turn on to AC voltage. Let's turn our display light on. If I look, a multimeter in this mode is high impedance. In other words, it's just trying to measure voltage. It's not trying to draw any power from that voltage source. On this wire, I'm measuring 123 volts. On this wire, I'm measuring 107 volts, 108 volts. Now, because you know that one of these is a ghost voltage, you're going to tell me, well, the ghost voltage is 108 volts. If you were an electrician working in a factory and you had two wires coming out of a piece of conduit, and you measured 108 volts coming out of that one wire, you're not going to know if that's a ghost voltage or not. That's well within the limits of being an actual real voltage coming out. Now, how can you determine if it's a ghost voltage? Well, since this meter in high impedance mode is not trying to draw any power, you can try to draw power. So when I'm looking at this 123 volts, if I hook up a light bulb to draw power, well, I'm drawing power and I've still got 120 volts coming out of that wire. If I were to move over to this ghost voltage and see my 108 volts on there and hook the light bulb up to that, well, guess what? It tries to draw power. There's not really any power there. Now I'm getting my true voltage. I'm seeing that it's not 108 volts. It's less than a volt on this wire. So this is my ghost voltage. Well, if you're an electrician, you're not going to carry around a light bulb or some other kind of a thing that's going to put power or try to draw power from the source that you're trying to measure. So in this case, let's go over to the low impedance mode. In low impedance mode, I'm trying to draw power from what I'm measuring now. So when I put this on the live wire, I will still see my 123 volts, 122, because this is the live wire. It can actually draw power. When I go to this one, let's turn our light back on. When I go to this one, I'm knocking that voltage down because of the low impedance. I'm seeing less than a volt. I know that this was a ghost voltage on the line. This is not actually a live wire. So a low impedance function is a necessity on a meter as far as I'm concerned for an electrician. When you're dealing with long runs of wires, when you're dealing with things that are coupling in, you don't know if that's a real voltage until you try to draw some power from it and understand what's happening. And a low impedance function tries to draw that power, lets you know if you really have a voltage there or if you have a ghost voltage.